and I wish everyone the wishes for everyone. Kindly mute your mics for some time, and during Q&A session you can take it up. And today we have two important topics. One we have just completed about the solar, and other one is rainwater harvesting. This is the need for our. Once the thought was raised, immediately I approached Vijay sir. Vijay sir is the number one in rainwater in India. He's having a lot of credentials, and they are into research development, and
Okay.
they are doing lot of projects. I introduced Mr. Vijay sir to
Okay.
you, and he is the director of Farmland harvesting systems. He is going to give an idea about the modern rainwater harvesting system.
So we are not interested.
Buying
Not
water
interested.
these days, and water is the biggest issue. So how we can become a Mr. Srinivas, will you mute your mic, please? Mr.
Yes.
Srinivas? Yeah. Yes, mute. And this is very much indeed required for the need for our, and everyone is fighting for water, and they are having a lot of issues, means problems. They are not able to get basic things. Means water is a important element in everyone's life. Without water, we can't live. Any building without water and without electricity is dead. So he is helping a lot of communities by harvesting the water. So thought of in the World Environment Day, we thought we should do something appropriate by giving education to the people. So sir has immediately accepted our request, and his firm name is called Farmland Rainwater Harvesting Systems, and they are doing a lot of projects in all over India for the industries, for the government, especially government. Lot of projects they are into. Next 1 hour, sir will be giving you details on the how we can effectively save the water, conserve the water. Yes, sir. Welcome to our session, sir.
Thank you. Thank you so much. Can I start, sir?
Yes, sir. You can start.
Yes.
The participants will ask
Yes, sir.
questions later.
No problem, sir. No problem. Absolutely no problem. Happy evening, everybody. As you all know that today, India is a water-starved country. Though we get an average annual rainfall of 1,170 mm, still there is shortage of water. In the year 1947, when we got independence, with 30 crores of population, average we had about 5,000 meter cube of water availability per person. Today, with the increase of the population, our availability of the water has gone down as low as 1,500 meter cube per year. This means to say that anything below this will be a lot of distress. India is already a water-starved country. Here we are at a crucial junction now. If at all anything below this will be in a huge problem. Today, it's a point has come where we all join hand together to reuse the rainwater, to reduce our usage of water, so that we make India water self-sufficient. In India, we have always worshipped water. Here, Jal is Jagdish. Around the world, everybody is talking of saving water today. But they say, according to the survey done, out of about 17 countries in the world will face a severe water crisis. And it is very unfortunate that India is one among the top 5 countries. Every year, we are extracting 1.5 times more the water that we are recharging. With so much availability of the rainfall at 1,170 mm, still we are facing a huge shortage of water. They say that all dams, all ponds, all lakes, well, and even the percolation all put together, we are able to save only about 35% of the water that falls on the earth. The rest all is going as waste and joining the sea. We are extracting so much water. 65% of our water dependency is on the groundwater. Today you'll be surprised to know that the borewell depth has gone below 1,500 to 1,800 feet. This has caused a lot of distress. You have seen a lot of suicides happening in farms because to drill this kind of 1,500 feet borewells, the drilling cost and the pump cost, each borewell will cost you, around 4 to 5 lakh rupees. Imagine after you drill, if these borewells dry up, what is the fate of the farmer? Let us take example of Karnataka here. Out of the every 10 borewells drilled, 6 borewells don't get water at all. During the drilling also, during the drilling time only, they are dried. Out of the 4 borewells where we get water, within 1 year, the other 2 borewells fail. So the strike rate of the borewell is hardly 20%. And the cost of drilling the borewell is around 4 to 5 lakh it is coming. And if the strike rate is only 20%, imagine what is the state today. On an average, it rains about 45 days in India. In 45 days, we get about 90% of our rainfall. In India, the majority of the water, everywhere in the world also, the majority of the water is used for agriculture. So this is one place where we'll have to look for a lot of innovative things to save water, to reuse and recharge the water. Where we have to plan of recharging their borewells, construction of the ponds, and storage of the waters by anekattos, and percolation of the water into the ground. Just to give you an example, how important, how we can, if we all join together, how the things can be changed. Whenever we think of water, to us, Israel comes in front of us because Israel was found in year 1935. 2/3 of its land is dry or at least less rain zone. 1/3 is a marshy land. On an average, they receive only 100 mm of rainfall, whereas we receive 1170 mm of rainfall. They just receive 100 mm of rainfall. With their innovative technology to save rainwater, to reuse and reduce water, they have enough and more water. Today they are with surplus water, wherein they are able to supply water to Jordan and Syria. Whereas with so much of rainfall here, we are still searching for water. Where is the disconnect happening? Why, when rainwater is such a wonderful thing, why is that people are not adopting to the rainwater? Just to take the example, what is the potential of the rainfall? I just take the example of Bangalore and explain you how much is the potential of rainwater. In Bangalore, we get water from Kaveri, from KRS, from about 108 kilometers the Bangalore, we get water to Bangalore. Every day they supply about 1250 MLD of water. And apart from that, they say that we extract about more than 450 to 500 million liters of water from the ground. So about Bangalore's consumption today is about 1600 to 1650 MLD of water. They spend about 1.3 crore rupees on electricity bill alone to pump this water at the height of 1000 feet to Bangalore. Now, to tell you the importance of the rainwater, if at all just theoretically assume that we are able to cover Bangalore with a plastic sheet, and the amount of the water, rainwater that falls on it is collected, stored and reused, you will not believe when I tell you, without any Kaveri, we will be able to supply 3000 MLD of water, double the water what we are supplying today for 365 days. That is the potential of water. Here in Bangalore, we have got many houses wherein they are just using rainwater. They don't have got any of the connections from the BWSSP or from any borewell. They have got enough and surplus water there. If they can live, we also can live. Just an area of just 1000 square feet, a small house by 30 by 40 at 1200 square feet roof area. With Bangalore's rainfall, you get about 1 lakh liters of precious clean distilled water. So imagine the amount of the water, colossal quantity of the water falling on every house. There are estimated that we have about more than 22 lakh houses in this Bangalore. And this is the same in all the other cities. With 500 mm of the rainfall, if it is harvested, collected, and reused properly, there is enough and more water for what is required for the city. Still, we are starving for water. We have virtually fought wars interstate. Hope we have not forgotten the days when we had virtual war with Tamil Nadu or Kaveri. We are heading towards that. They say that it's very oftenly used that if there is a third world war, it will be for water. And who else know it better than people of Karnataka? We have got problems with Andhra for Krishna. We have got problems with Kaveri. It is same with the countries also. Like we have got over the river Ravi, we have got problem with Pakistan. Over Brahmaputra, we have got problem with China. So each and everywhere there is a water conflict today going on. How we can adopt rainwater harvesting, and we can change the scenario from water distress to water surplus country. It is possible. If Israel can do it, for us 100% it is possible, 10 times better. Now let us come to what are the laws in Bangalore, how the government has though made mandatory for rainwater harvesting. Still, why rainwater harvesting is not been very successful. Next slide, please. So this is you can see the rules according to the BWS Act of 1972. Any house that has got more than 2,400 square feet of rooftop area, today they have to mandatorily do the rainwater harvesting. Otherwise, they are fined. You'll be surprised to know that recently I was reading, government has collected about 15 crore rupees as fine alone. People don't mind paying fine for not doing rainwater, but they don't want to implement rainwater. And rainwater harvesting is such a wonderful thing. You'll be surprised to know why it is not been implemented. There are 2 or 3 main reasons for rainwater not being made is not very popular among the people. One is the faulty installations. When they are installing, though rainwater is not a rocket science, which I always tell. But if you are not at least using a little bit of common sense or little bit of your engineering knowledge, then the whole rainwater harvesting fail. One is that. Second is the use of the faulty filters, because these days wherever the filters which are available in the market, many of the filters, more than 95% of filters which are available in the market are not self-cleaning. They need to be maintained after every rainfall, which is not happening in the houses also and in the public domain also. So after 1 or 2 rainfall, these filters get clogged, and then the whole rainwater harvesting system is for a toss. Next slide, please. Here you can see the simplest way of the rainwater harvesting, wherein all the downtake pipes are interconnected to a horizontal pipe, and these are brought towards the tank. You install one filter in between, and the filtered water is let into the tank. Overflow from the tank, you can leave it to the borewell or the open wells. When you are installing this kind of system, one thing you have to be very careful is, see, when you are putting a vertical pipe, as I'm speaking to a lot of engineers here, you'll all be knowing that when you're putting a vertical pipe, just clamping it with a C-clamp is more than enough. But what happens is, if you are using the same C-clamp for a horizontal pipe, then the whole system get failed. Because when you're putting a horizontal pipe, the weight of the pipe as well as the weight of the water, when it is raining, the weight of the water is on the clamping system. So the clamping system has to be very, very strong. And these days, when we are using these hollow bricks for construction, it becomes still more important that we have to fortify the clamping system so that it can take the load of the pipe as well as the weight of the water, so that it doesn't come off. Majority of the times, wherever we have seen, because of these kind of wrong clamps being used, the whole system is getting off in 1 year. That is one of the reason. Next. And second, one of major problematic, the main area is the filters what people are using. In the conventional filters, what you are seeing on the right hand side, what happens is, whenever it rains, all dust, debris, everything comes and settles down there. And after every rainfall, you have to manually remove this and throw it out. And because they are not able to find sediment comes and settles on the top of this kind of conventional filters. So they have to be cleaned very frequently. Otherwise, the whole filter system fails. If you are not able to clean the leaves, dust and debris, the organic matter starts getting decayed in after 45 to 50 minutes of its falling, and then the whole when there is a next rainfall, the whole degraded material happens to pass into the water, and then that is the reason you always hear the rainwater you have small worms growing or rainwater smells. Believe me, my friend, rainwater is the purest form of water. If rainwater stored in a tank with a closed cover and where you don't allow sunlight and the air, you can keep rainwater for 100 years. There are a lot of instances in the India which has been proved in Rajasthan and Jaisalmer areas, where in the olden Havelis were hundreds of years old Havelis which had rainwater tankas and which were closed. After 100 years, when they were removed and the water was checked, the water was pure as it was when it put. So rainwater is the purest form of water which can be stored for 100 years without getting contaminated or without water getting stale. Only thing is you have to take care that you don't allow light and air to interact with that one. Next, here are the filters you commonly see in the market. Here, if you see at the bottom side, you have got a ball wall in all the filters. So what happens is whenever it rains, all the dust debris come and settle down near the bottom of the filters. And every rainfall, you have to go and open this ball wall, which in our busy schedules we fail to do. And if you're this because of this, accumulation of the dust and debris there, if you are not removing after one or two rainfall, whole of the pipeline will get choked, and then it starts flooding in the roof. So that is one of the major reasons why how the rainwater harvesting systems have failed. Next. Now in India, you will find first of its kind filter which are self-cleaning, maintenance free. Why it is maintenance free compared to all the other filters which are available in the market? These filters are open-ended and auto flush out filters, wherein what happens is all dust, debris, everything goes out automatically and the clean water comes on the other side. These are the maintenance free filters which have been developed after research of last 5 years. Next. In this filter, you can see on the left hand side, the cross section of the filter. Here, all the dust, debris, everything falls out automatically, and the clean water is coming on the other side. One more advantage of this filter is what happens is first 90 seconds of the water goes out. This filter works on cohesive force and centrifugal force. Once installed for next 30 to 40 years, there is no consumables required. Nothing need to be changed. So that becomes one of the easiest way to install, and it is a retrofit filter. So these are the kinds of the filters which are available in the market, and they have become very popular today. And where people have started using rainwater in a bigger way. Next. Today people have understood the importance of the rainwater everywhere, and large industries, schools, or apartments, everybody have started understanding the importance of the rainwater and have adopted the rainwater. Rainwater is not only doing by adopting rainwater, you are not only doing a human service to mother earth by saving water. If you take it commercial point also, the return of investment on all your investment you do for the rainwater harvesting is hardly 3 years time. Because you're saving on your water bill, at least minimum about 150 days to 180 days with your existing tank, you can have enough and more water, so that for those many days you need not buy water from the BWSSP or your water supply, so that you can save on your water bill. And this is one time investment, it can run for at least 25-30 years without any problem. Next slide please. See, today each and every states have started giving some perks to adopt rainwater harvesting. This is a slide you can see. It is from the Bhubaneswar, means Orissa, wherein government has made it mandatory for everybody to go for rainwater harvesting. It is not only mandatory; they provide you a subsidy of 45,000 rupees if you install rainwater harvesting for your house. We have installed more than 2 lakh installations in Bhubaneswar and around other districts of Orissa, wherein government is giving you 45,000 rupees subsidy to install a full-fledged rooftop rainwater harvesting, and then the borewell recharging system. So today, government is taking up, more interest. You have seen that Jal Shakti ministry, a new ministry has been formed this time, wherein they have allocated about more than 3,000 crore rupees for, just create the awareness about the rainwater harvesting. Next slide, please. Next slide. Yeah. One more important aspect is about recharging the groundwater. What happens is, you have seen that groundwater is one thing which is falling very, crucially. Every year they say the fall is around, more than half a meter in some places, and it has in some of the crucial dark zones it is more than 2 meters. This is very, drastically it is going on, and at this rate probably we will surpass the rate, date given by the Niti Aayog to run out of the water. We have to save the runoff water, because that is a huge quantity of water. Just if you take 1 acre of land, just for 25 you get about 1 lakh liters of water. So, imagine if you take Karnataka's average annual rainfall of about 800 of rainfall, still you get about 35 lakh liters of water, which is, going waste. And generally, government. Next slide, please. Everywhere it is, you can see on the right hand side. Everywhere government tells that we have to go for pits, make a pit of about 15 to 20 feet, then fill it with gravel and brick bats and all, and then leave the water. But I don't know, by our last 20 years experience, we have seen these kind of pits help us only to recharge the subsurface. And if we had wells around, this would have been the best option, because subsurface recharge, it will recharge the subsurface. If you have the well, then if you are able to remove the water again and use it, then this is the best system. But now, because we have forgotten the wells, we have forgotten our olden knowledge. Our forefathers were more knowledgeable in waterfront than what we are today. They had enough and more water. Those days when Kempegowda ji built this Bangalore, they say that there were about 970 lakes here. Today, in the name of advancement, or in the name of calling ourselves as more intelligent, we have closed those lakes and made them as industries or bus stands and railway station. Our own majestic bus stand is Kampapati Kere, and our stadiums and our stadiums all were Kere, means lakes. Today we thought that we don't need this, because in 1970 the Borewell started. Generally means it is those period that we started drilling the borewell, and today we'll be surprised to know that we have got more than 22 lakh borewells in and around Bangalore. So where we are heading towards, if we are able to put this kind of straws into the mother earth in this small area, and if you are extracting water without recharging them, how many days do you think? Because in the earth crust there is no mechanism to produce water. Whatever the water which has taken millions of years to go and accumulate there, we are just putting the motors and extracting. That is the reason out of 10 borewells, as I said earlier, 6 borewells fail, and then hardly 2 remain after 1 year. So this is what is happening. So what will happen to the next generation? Like me and Ashok sir have completed half of our life and hardly left with some few years to go. But what happens to the next generation? What happens to your son, your grandson, and my young engineers who are listening to us? So what will happen to you? Next. They say that, according to the BBC report and a Niti Aayog, they say that Bangalore will be the second city in the world to run out of the water, and that too not very far. It is 2025. They say 50% of the population will have to be evacuated. Imagine what will happen to this high costing apartments and high costing land, all this, when we don't have water. Can you imagine one day without water? If you go to Sarjapura area and North Bangalore, the water tankers today, 1 kiloliter of water is charged 200 rupees. Means the tanker is charged somewhere around 1,000 rupees. If this is the state, do you think we can buy water at that rate and can we survive? It is really impossible to think of. I have seen in Sarjapur where they had made swimming pools during the sale of the apartments. Today, those swimming pools are used to store rainwater. They have converted one of the swimming pool. You'll be surprised to know to store the rainwater. That is the stage we are heading towards. Now coming back to the this one, I was talking to you about the recharging pits. So recharging pits doesn't help to recharge your borewell. The best example is you have seen lot of lakes around Bangalore. Okay, each of the lakes will have 365 days water. You can see, like if you take in the South Bangalore, we have got Edur Lake. If you go to the North Bangalore, then we have got Hebbal. In the center, we have got Sankey Tank, and Halsur Lake and all. These lakes have got water for 365 days. They are deep, at least minimum from 25 to 30 feet minimum. They are deep. Still, then if our recharge pits could have helped, as told everywhere, then the borewells drilled next to these lakes, we should have got 5 inches of water. But that is not so. If you go to the Sankey Tank, in the walking track of the Sankey Tank, there are borewells which are dried up. That means to say the water which is stored in the subsurface is not penetrating down to the aquifer from where we are drawing the water in the borewells because of this clay mix soil at the top, which goes about 20 to 60 or 80 feet, and then sometimes then we have got hard rock which is not allowing the water to penetrate. So next slide please. Yeah. So what happens is, with our continuous research, we developed one system called Vijay injection well, which is developed by our company Farmland Rainwater Harvesting System. In this V-wire injection well, what we do is we do a geophysical survey first and identify the first permeable zone. The first permeable zone after this, overburden of clay and rock, and go to the first permeable zone where we find fractures or we have got sandy loam soil or weathered rocks. So we drill it up to that level. 8.5 inches borewell is drilled to that depth. And once the 8.5 inches borewell is drilled, then we have we use one special component called V-wire screen, and this V-wire screen is fixed at the bottom one and is connected to the pipe, which is perforated, zigzag perforated high density polyethylene. In 8.5 inches drilling, we just put 5 inches pipe, which is perforated, and rest the space in between the 5 inches pipe and the 8.5 inches drilling, we fill it with pebbles. And then we create this kind of structure. You can see a structure over here, kind of a system. And in this well, we keep this whole well empty. Generally in the pits, they ask you to fill up the brick bats and fill it up. But we keep this whole well empty. And only at the top level, what we do is we'll put the filtration media. Like the filtration media, what we do is we fortify this filtration media with charcoal, chlorinated activated carbon, silica sand, gravel, and pebbles. And then this is connected to one of the silt traps. We make silt trap which is about 10 feet depth. And this silt trap is connected to the filtration media. So the water is allowed to enter to the silt trap first. And from there, because of the siphoning effect, this water will enter into the main injection well, get filters through this filtration media, then goes and joins the well, the empty well. So this empty well acts as one as storage, and second is it will create the kind of the water column, to push the water into the deeper aquifers. So if you measure the pressure at the bottom, you will find that 4 bar pressure or to 6 bar pressure that is created at the bottom. So with that pressure, it opens up all the dry joints and cracks, and the water is stored there. Next. We have installed this more than 18,000 of such injection wells throughout the country, and even if the dried borewells have been rejuvenated, we have seen that because as I told you, there is a huge potential of the surface runoff water. Here in this slide, you can see if it would have rained, all the water would have gone down, and our borewell is at this right hand corner. Yeah, you can see this borewell is at the right hand corner. So we installed one injection well system. What happened was, all this water which would have otherwise gone waste and caused some water logging at some lowest low-lying area, we allowed this water to go into the silt trap, and from the silt trap this water is allowed to go to the injection well. Generally from a drinking water borewell, we do injection well which is about 15 to 18 feet away from that, and then go, as I said earlier, this water is allowed filtered through the filtration media. It is allowed to go to the first permeable zone. Thereafter it gets filtered through the earth crust and then reaches the aquifer. You'll not believe if I tell you 1 meter by 1 meter of compressed earth is the best filter in the world. No other filtration unit can match that kind of filtration unit. So when the water is filtering through the earth crust, because we are water, our borewells are 800,000 feet deep, and we are just leaving this at the first permeable zone, which we generally have seen that we get that first permeable zone at the depth of about 140 feet to 240 to 50 feet, depending upon the different zones. Next slide, please. Here in this slide, you're seeing two rigs. You'll be surprised to know that these are the first two rigs in the world which has been developed not to remove the water. Generally, if you see a bore rig, it is to remove the water. But these are the first two rigs which are specially developed, wherein these are meant only to recharge the water, not to remove a single drop of water. So these are the special equipments which have been developed. So you have a scientific methodology to recharge the groundwater. Next slide, please. These kind of recharge wells, are used both in the urban and rural areas. You can see high-rise apartments have been using this injection well to recharge their borewell. These have been found a very great acceptance in avoiding the waterlogging also. These days we have means I'll explain it in my coming slides. These kind of injection wells have now been used in urban areas in the cities where there is a lot of waterlogging. You can see in Bangalore, if it just rains about 40-50 mm, the whole of the Bangalore is flooded. Everywhere there is water stagnation, and majority of the water stagnation in the lower lying area where there is a loss of life and property. Next slide, please. These have been proved and tested in each and every department of government of Karnataka and India. Majority of the has been in the pilot project. It has been taken. Then they have installed it, and once they were successful, they were replicated in the other areas. Next slide, please. This is one of the beautiful case studies of one Mr. Bettamaraya, a farmer in near Tumkur. So here what happened was when we met one Secretary Sri Naveen Raj Singh sir, wherein he said that I see a lot of good presentation from you, but I want to see your how it happens in the ground reality. What is the ground reality? So we were provided with one dried borewell of this farmer. He had about 3 borewells in his this one. All of them had dried. His children's, because there was no water available and this land was totally dry. So their children's had moved to the cities to work and earn. So we took up that borewell, and then we recharged. Fortunately, we had 2 very good monsoons after the recharge, and we could recharge the dried borewell. You can see this photo was taken in a deep summer. Only his land is green, and rest you can see on the backdrop all dried, this one. Because this water table came up, we could implement solar pumping system, because the water table was up. Because if there is a deep borewell, deep water table, then still we don't have sufficient pumps which can lift water from very deeper aquifer. So because the water table came up, we could install this solar panel also, and then drip irrigation and sprinkler system was provided, and it was a very successful story. Thereafter, we got a lot of appreciation from the sir, and he always used to promote these kind of technologies, and a lot of experiments were done. Next slide, please. This was the appreciation letter issued by Sri Naveen Raj Singh sir. Next. In slide before, please. No. Yeah. A lot of industries have gone for rooftop rainwater harvesting, wherein they are using this rooftop rainwater even for drinking, with small filters adopted. You can see here on the left hand side, all the water is collected, passed through the rainy filters, then it comes, and then we have got activated charcoal filters installed here, and these waters are being used for drinking. This is one of the installation on Khanija Bhavan on Racecourse Road. Next slide, please. In majority of the rural areas, in their drinking water projects, these injection wells were adopted. In Chamarajnagar, where we installed about more than 240 injection wells, when we had applied for Earth Care Award for Times of India, whole a team of about 12 members from which included eminent scientists and from the different walks of life. They came and visited Chamarajanagar to find out. We had done this recharging installations about 240 in the year 2010, and they came. We had applied in the year 2012. When they had come and visited that Chamarajanagar, they were surprised to find out that only those borewells, because there was a drought in the 2 years continuous drought and scanty rainfall in those areas of Chamarajanagar. So it was found that only those injection borewells which had injection wells were working, and we got about 5 lakh rupees cash prize for that project which we had done from Times of India. Next. And then these were implemented and extended to more villages, because there was a success stories were there, huge success stories. Next. This is how, here you can see this. These are in the major IT industries which have got very big campuses. So what happens is, because majority of their campuses have got buildings and then paved area only means, so what happens is huge water from these campuses goes out, used to go out. You can see the swales here. So we installed these injection wells in the swales, so that this water, whatever their campus water is there, which doesn't go out. So means the campus became zero discharge campuses. One of the campuses in the software park, we did it in Chennai. There 40% of their requirement, annual requirement, is met by the rainwater alone. And you will be surprised to know that campus has got 25,000 seats. With 25,000 seats, when with their staying facilities and all, still they could do that 20 means 40% of their annual requirement can be met by rainwater alone, and they recharge the groundwater in such a way that the lot of water was available there, and there whatever the water which was falling in the campus is not allowed outside. Here also you can see this water from the roof is brought, and then we created large tanks. Side, the huge tanks have been created where this water, this is about 3.25 lakh liters tank. This tank built by us only, with a very low cost tank. It is a low cost technology, and then these waters are filtered through the silica sand activated carbon, filtered and stored here for the reuse. Next. Here you can see this campus is about 3,60,000 square feet of roof area. That means to say, for just 25 of rainfall, you will get about 7.5 lakh liters of water. Here you can see all these downtake pipes were joined together, and then they were brought to a common point. Filters were fit, and this water was stored and further reused. So they had enough and more water there, so that they were thinking of giving it to the tankers or selling it to the tanker fellows. So much of water was getting collected in a small rainfall. Next. Here, one more thing we'll have to, because we are all having a lot of engineering students here. One more thing during installation we have to take care of this is, you have to provide a proper overflow pipe. Means you can see here in the first, you can see a overflow pipe. This will act as a air vent also, because when you are running a pipe very long, there is tendency that air blockage will happen, because we need some air outlet, air vents. So this act as air vent also, and then this act as overflow pipe also, because these days what happens, because of change in the climatic conditions, there are intensity of the rainfall is very heavy. Now people generally, if you go and talk to our elderly people, they say, "Hey, now the rains have come down, rains are not coming, in our times it used to rain so much." If you go to the meteorological department and check the data, you'll be surprised to know that not even a single this one of rainfall has come down. In fact, some areas rainfall have increased. But what has happened? What they are telling is also not lies. But what has happened is, because of the change in the climatic conditions, the intensity of the rainfall has increased. Now, whatever the rainfall in my childhood days, I could see, if it is rainfall, it is a minimum 3 months of rainfall. Every day it used to rain. You used to get small rainfalls, slow rainfall. But now what has happened is, it will rain. You have seen rainfall in Bangalore. Recently we saw. Suddenly in the evening it will come, heavy rainfall. So your quota, your total is matched. But what happens is when there is a rainfall, heavy intensity of the rainfall, it is one is that you are not able to store the water. Second is that when there is a heavy intensity, there is a large runoff. Water will not percolate. Though our annual total tally gets tallied, but still we will be having lack of water. Next slide, please. Here also you can see this is a garment industry where they required huge water and they wanted demineralized water. They were spending a lot of money on their processing of the water because of the dyeing and all they require demineralized water. So rainwater being the purest form of the water with TDS of just 35, as good as any of your RO water, and without any minerals. So all the rooftop we can see they're connecting all the rooftop, all their roof, because they have a huge roof areas. You must have seen garment industries and all where they have got about 3,000 people working and huge sheds. They have all this water is brought here, and then when this water is conveyed to the one jack well system or a pumping well, a well is made here about 15 feet, and all this water from the jack well is pumped to the filter. Here you can see these are the customized filter which can and take the load from 50 meter cube to 500 meters. 500 meter cube is 5 lakh liters per hour. That kind of filters can be customized, and then this water is fed into the tank for their reuse. Next. Here you can see what we have done is generally what is happening is world over they have changed from PVC pipe to HDP pipe, because they say that PVC pipe is carcinogenic to supply drinking water. So in world over they have changed to the high density polyethylene pipe. Here you can see these are gray color high density polyethylene pipe, and their life also is more, means they have got lifespan of at least 40-50 years. And here whatever you can see in the here we install water meters. We have installed you can see at the end of the left hand side that first figure. Yeah, we have installed, yeah, these are the water meters, because unless we measure it we cannot save it. So water meter has been installed. One is to calculate what is the return on investment, how much water is saved, and then because it gives us key, what kind of water, what kind of investment we have had, and how we are getting back the returns. You can see this air vents also, and there is a huge piping system. These kind of the air vents have been put. So this is how a typical installation takes place in a bigger campuses where you have to store huge water and reuse the water. You have seen on the right hand side there is a jack well system with a pumping system. With all the ball walls. These are all customized designs which we have installed in many of our industries throughout the country. Next slide, please. This is a part of the same installation, wherein you can see on the right hand side, these are the V-wire screen, horizontal V-wire screen, so that when the water is coming, all the leaves and floating particles is, stays here. Only the clean water comes from the jack well system. From the jack well system, this water is pumped to the filtration unit, and from the filtration unit, this water is pumped for the utility. Next slide, please. In the smaller areas, when you have got smaller rooftop, then what happens is you can see the filters availability are about 4-5 types of the filters are available depending upon the roof areas. But when you have got larger roof areas, you can put parallel filters like this. Here, in this figure, you can see about 6 filters. That means to say this is about covering about 30,000 square feet of roof area. Each filter can cover about 5,000 square feet of roof area. So about 30,000 square feet of roof area, this is covering. All this clean water is connected to a single line. The wastewater line is connected on the other side. And also then you can save a huge quantity of water. Means 30,000 square feet of roof area is about 30 lakh liters of water annually. So that's a huge saving. Next. We have installed about more than 3,000 schools in Karnataka alone. Here you can see a hand pump, yellow color, that is a hand pump. Wherein here what happens is we install this gutter with special clampings, and then the filter was installed, and then under this hand pump we constructed a tank, and then we provided a hand pump. We provided a hand pump because we wanted children to earn water, not to get water. What happens is when we are getting water, we will not know the value of the water. So we wanted to inculcate the value of the water into the children's mind, because each child is each family. One child is one family in the coming days. So we said the knowledge of saving water should come from them. there. So that's why this water we provided hand pump for a different type, innovative type. We said we should provide them hand pump, and so whenever they want, they should pump use some energy to get the water. Next. This is again about 3,600 schools in Assam. We, installed this rainwater harvesting system. Here also, what we did was on a platform at a height. We created about 10,000 liters of tank, and then the filter was fitted at the top. And then this water was used for the schools there for their cooking of the midday meals. What happens is in Assam, though they have got heavy rainfall, but what happens is there is a lot of iron content in the groundwater, so that becomes a huge problem for them and the filtration unit. So this was the easiest and the cheapest available source for them, because that rains about 3000 of rainfall, and it rains about more than 100 and 150 to 160 days of rainfall they get. So it was sufficient for them for their daily needs, so that they could use the rainwater and avoid this filtration cost and the huge capex investment for and the maintenance cost for the filters. Next. These are the few photographs of where household peoples have installed the rainwater harvesting, and how they each one has got one story. How they're used to buy tankers, and how their water was, the quality of their borewell water was bad. After mixing this rainwater, because of the dilution effect, the quality of the water got improved. So we have got thousands of stories to tell. If you allow me to speak, I can speak for another at least 10 12 hours and keep on talking about it. So many successful stories we have to share with you. Next. This is in the Konkan Railway. In the Konkan Railway, from Madgaon to Mangalore, in the whole of this area, they get a huge rainfall, about 3,000 mm, I think, average annual rainfall there. But what happens is during the summer, from the month of the February, because they are very near to the sea water ingress happens, or all their borewells and open wells start getting saline water. So we started installing these kind of the structures, and we tried to push back the rainwater into the open wells and all. So because of that, the seawater started, ingressing stopped. This is what was first installed in Tamil Nadu also during Jayalalitha's time, when she first started this recharging pits in that Triplican and all those areas, that seaside belt, where the seawater started coming in, all the borewells and the wells started getting water. So that is the reason first rainwater harvesting in a massive way was started by Sri Jayalalitha, to put that water back into the earth, so that that we can avoid that seawater getting ingressed. So this has been adopted, and still these were adopted long back. Still they are working fantastically well. Next. These are some of the larger industries where they have installed huge buildings. Next. This is one of the unique installation which has happened in Hassan. This is an indoor swimming pool. Here, you'll be surprised to know that there is no water supply to this swimming pool. A swimming pool without water supply. It is using its own water supply from its roof. They have constructed about 2 lakh liters tank. So all the water from their roof is collected and filtered through the rainy filters, and it comes and stores in this 2 lakh liters tank, and they have got enough and more water. Then they require. They're able to supply to the nearby community so much of water they get from their roof areas. So this is self-sufficient. If a swimming pool can be a self-sufficient, our houses can also be self-sufficient. As I told you earlier, there are so many houses in Bangalore which don't have got any water connection at all. And here, sorry, last slide, please. One more slide. No. Yeah. Here you can see this is one of the sites from Kumbhalgod factory, wherein they take this rainwater to manufacture whiskey, because what happens is they need a lot of processed water for manufacturing whiskey, and rainwater being the purest form, they can save a lot of cost in processing this water, which they take it from the borewell or any other source. Because they get the purest form of water, their processing cost has come down, their electricity cost has come down, and during the processing, generally there is because of the high TDS, 50% of the water used to go out. There was wastage of water, but because of this rainwater, they constructed 4 lakh liters tank and put all the roof water from every corner to that tank, and then they are using this rainwater for their process of making whiskey. Next. One of the more when one more important advantage of this injection well is to avoid these waterlogging problems. Recently, we tried. You can see our BBMP commissioner sir in this picture, wherein tanker water was brought in the underpass. A V-wire injection well was constructed because if you must be aware, very well aware that during our small rainfall also, the first thing is all the underpasses in Bangalore will choke up. It will become a endangered thing for life and property of the people because of the water stagnation there. All the vehicles will get damaged, people will fall, life and property is damaged. So now what has happened is we have constructed the injection well in the center of the bypasses, underpasses, and then it was tested. We got about 10,000 liters tanker, and this in 7 minutes this 10,000 liters could be percolated. So thereafter, we got a pilot project to install the injection wells in all the underpasses. Next, you can see here, that how this injection wells in the underpass. You can see on the side of the wall how much the water used to be stagnant. You can see that dirty part. So that much of water used to be stagnant here. Now with the injection well installed here, we have got a sill trap system, then an oil and grease trap, and then we have got the main injection system. Next slide, please. You can see here, Commissioner sir is watching because the water is led from the tanker and how the water is getting percolated into the ground. And it has been very successful even during when it rained recently in 4 hours, we had 104 of rainfall, but not even a single drop of water was stagnant in this underpass. Next. Next. There's a video, small video, you can see that if it is able to play. See. You can see this, all this water is coming, and we have got an inlet over here, and then nearby we have got a grease trap, so the water is entering here. All this water is entering from here, and it goes to the sill trap first. From the sill trap, it is allowed to go to the injection well. There again, it gets filtered, and this filter water is going to about 240 feet is the zone where there is we have found the permeable zone. You can see the tanker water is let inside to test this. Next slide, please. This has been very widely accepted in the national highways also. This kind of injection well has been installed. You can see our Minister for Transport, Sri Nitin Gadkari, after we met him in one of the seminars, we were promoted to do a lot of injection wells. Then our H.K. Patil sir, who was the Minister for Rural Development in Government of Karnataka, then we had the opportunity to meet him, and a lot of borewells of the farmers were rejuvenated. Next slide, please. These are the various top level government officers of secretaries at top level Indian government of India's top secretaries, and different types of demonstrations. Next. And we have got one more we have got a research station at Chikmagalur, wherein we train the people who really want to be a water warriors, who really want to implement these kind of rainwater harvesting system. So we train the people free of cost. We make them as one of the water warriors, because today it is the need of the hour that all the young engineers learn to make self-sustaining houses, which is very, very important, because tomorrow water, air, and if you are not able to make houses which are self-sustaining, these houses will be of no use. So we have to plan these things wherein we reuse the grey water, we use the rainwater, and make these houses self-sustained. So what we do is we give them a crash course, train the young budding engineers or anybody who want to really take it up as a profession. There is a huge scope in this profession. I want to share with this young people who are listening here. You can take it as as your career, wherein you can make name, fame, and money. And you will be doing a human service to the Mother Earth and the future generations to come. It is one business which can give you satisfaction for doing something for my fellow being. I will be very happy if at all you can take this as a profession. At least in your days when you are building buildings, or some of your architects, you plan that there is enough and more facilities available to use the rainwater so that you don't allow this water to go into the roads and cause flooding, and then you can save lot that much of water for your future generations to come. Next slide, please.
They can become entrepreneurs.
Yeah, entrepreneurs. We can develop entrepreneurs who can be the future of the country, and we can make the people we can those who are predicted that India will be water stressed or water starved, we can prove them wrong in next 5 years. I'm very confident if we all join hands together, if each one of us understand our responsibility towards water, India will be water surplus. We'll be able to supply water to the neighboring countries as Israel does. That is the potential of the rainwater here. But only thing is, that each and every person has to understand his role in conserving water, in reusing the water. If we do that, probably we can prove everybody who has predicted wrong, and make India water surplus, because water is life, and without water there cannot be any means. It will be such a bad state. You cannot just imagine to spend one day without water. Next slide, please.
Sir, next slide.
Thank you.
I have included.
Thank you, sir. Thank you so much.
Okay.
If any questions are there, I would love to answer.
Questions are there. We'll see over there.